Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So it's my pleasure to welcome Eleni Julia from University of Alberta. So she's professor at Alberta, and actually she holds the Industrial Research Chair, which is sponsored by NSERC and IBM, I believe. So please, Eleni, go ahead.
Thank you, Tom. I'm very excited to be here, and thank you for the invitation. And what I'm going to try to do is tell you about work that we have been doing for the past 4, 5 years maybe. And it's about 2 or probably more projects. So here's a quick introduction to geography. That's Canada, close to the US. That's Edmonton. That's the University of Alberta with the right mapping software. I do love big maps. And this is us, the website of my team. It's Service Systems Research Group. And that's our building in our campus. And before I start talking about the work that we have been doing in collaboration area, I'll tell you a little bit about the broad spectrum of activities that we're doing. We're working, as Tom mentioned, we're working very closely with IBM. And we're doing several things with several of their teams. And the best we can do in terms of coming up with a theme is the Smart Planet theme. And the storyboard in that vision says that the smarter planet will be instrumented with all sorts of small and dumb devices, RFIDs and sensors, and other devices that people carry on themselves, cell phones and PDAs and tablets, and all sorts of new things that are embedded and possibly wearable. All of these sensing devices will collect data, and through data mining, we'll extract knowledge that will allow us to build models, which we will be able to simulate, to generate predictions, and that's going to be the nature of our intelligence that will provide to people to make interesting decisions. And everything will be interconnected because we'll have data on the same phenomenon, data of different types on the same phenomena, and the hardware and the software is being integrated with all sorts of fancy middleware, and people are becoming more and more interconnected by virtue of the fact that they exchange data and they share their interests and their activities on the web. So if this is the way things should become or will become, what we're supposed to be doing to make that happen, we have 3 major activities, 3 major projects. One is the Smart Condo. We're working with health scientists in rehabilitation medicine, primarily, and nursing. We're working with industrial arts and design people and educators. And what we have done is we have built a home. It's an 80 square meter space in which we have embedded sensors, and the sensors detect motion, pressure. There are switches for opening and closing doors and cabinets and appliances. And all this sensor stream gets analyzed both in terms of a simple stream mining component and with data mining in the database. And we extract the higher level representation of the activities that are happening in the home. And we then replay this history of what happened in a virtual world, currently Second Life and OpenSim. So in the end, what we end up having, at this point in time, we have seen that the video that we record in Second Life, which is generated by analyzing the sensor stream, is very close to what happened in reality. We basically compared a real camera feed and the Second Life feed, and they look quite close, which is interesting. And now we're working on all sorts of interesting devices. So I had a student build a smart onesie that monitors the baby's temperature and baby's motion. And we're working on a smart bike that will place kids with cerebral palsy in a virtual world so that they can compete and collaborate with their team members. And Tom told me that you're supposed to interrupt, so please do interrupt. It's better that I don't lose you. So that's the smart content. I'm very excited about that. The more traditional software engineering stuff that we have been doing started with legacy interface migration towards standard XML-based specifications. Back then when we didn't have the web services stack of standards yet, but that was the idea. We have done a lot of work on re-engineering, and we're continuing that to migrate towards service-oriented application standards, both web services and REST. The major project right now is using a simulation-based method for predicting the behavior of service-oriented applications deployed on different configurations in order to make a good decision for the initial configuration that will be deployed in order to meet some service level agreements, and we use the same repository of simulations to support autonomic runtime adaptation. And we're doing some work on economics of software engineering. In particular, we started looking at refactoring economics and configuration of service-oriented architectures. And finally, the thing that I will be discussing today is all sorts of tools for collaboration support, and more recently, training people to collaborate, again, in the health sciences. So these are the people who do the work. I currently have 13 students, and that guy here is the guy who runs Windows on his Mac and loves it. So what was the motivation for doing this research? Basically, we were both interested in the problem and in the technologies. And I must admit that the technology sort of came first. We started working with web services, and then we realized that more and more people made available interesting data that was available and accessible through XML, and the REST paradigm was becoming more and more prominent, and we had lots of APIs that supported collaboration. To begin with, it was tagging, but after that, it was georeferencing information on maps, and the FOF API came about, and people started talking about themselves and their friends. So there was lots of interesting data available and lots of interesting tools that allowed more data to be collected and analyzed through scripting languages. In particular, I was very interested in the notion of wikis as a platform for supporting collaboration, and that was very much part of the reason why we started doing this work. And then eventually it went to social networks as more and more social networks became available, and I started working with people who were interested in what motivates people in participating in communities from business, and how do you recognize and consumption, information production, consumption relationships, and how do you attribute information to people who might want that for credit. So that was more of the toolkit. Lots of things became available, and they were interesting, but in particular, we were very interested in the collaborative process itself, and I love this quote: the easier you can communicate, the faster change happens. Basically, communication collaboration is essential for all sorts of interesting things. And in the course of these 4 years, I have been interested in 3 fundamental things. One is, how do you do research? How do you help a research team do what they need to do and introduce new people to it? And for that, we started using Mediawiki in my lab. And the idea was that I would be talking with my students over the wiki, and we would have a record of what we did and the decisions we made and the problems we faced. And that was the beginning of things. And then we started using the same platform with new tools in the context of teaching people how to do software engineering projects. So I am responsible for teaching a 3rd-year course where teams of 4 or 5 have to build an interesting tool, and we figured that people did not talk to each other, and they realized that they haven't talked to each other quite late in the process. And then there was crying involved, and it would be nice if we could use wikis to make people happier, primarily instructors. So we built a suite of tools for distributed software development on Mediawiki. And more recently, working with our health scientist professionals, we realized that medicine and care delivery is going more to a team format, and the idea is that you want to eliminate the need to go to the emergency room. And it would be nice if you had a team of people looking at the person, so the nurse who visits and the family physician and the emergency physician are all working as a team. Now, the problem with that is that people don't know how to work as a team. And in our university, we have an institution called Health Science Education Research Commons, whose agenda is to build in the curriculum of all the health scientists some modules that will help them talk to each other. So there are issues of language sharing, and there are issues of merging their practices and working to deliver care. So in the end, we have 3 systems. The bold systems are the ones that I will be talking about, but there are other stuff in the periphery that I could be talking about if anybody wants to know. So Anoki is the tool that we are using to collaborate and do research. Reason is the tool which is built on Mediawiki, sort of parallel to Anoki, to do analysis of researchers' social networks. We have data from DPLP and the ACM Digital Library, and we have examined the social networks of people through the papers they write together, the papers they cite together, and the papers they cite of each other, co-production and influence. Wikidev is the suite of tools that we're using for software engineering education. There was an old Wikidev that kind of got scrapped. Wikidev 2.0 is the thing that I'll be talking about. and we're working on an integration of a 3D virtual world on WikiDev 2.0, and I'll show you a picture. It's not there yet. And MERITS is the system that we are using for training health professionals to do procedures together. So, as I was telling you before, you're trying to come up with a theory of how these things fit together, and that was not particularly easy, but that's the best I could do. If you're thinking about the space, I was thinking about what is the nature of collaboration and what are the tools that we have available. And if you think about communities that simply share interests and share information and publish recommendations and book reviews, there are all sorts of things right now. Wikis and social network platforms and virtual worlds are used like that. So you just have people together and they talk. They don't have anything particular to do. They don't have anything to accomplish necessarily. If you're talking about purposeful activities like software engineering, you have more specific tools that are more instrumented and they're tailored for software engineering. So the question is, could we use these default platforms that look so cool, and could we use the experience that people have using them to train them in doing more purposeful activities? And I figure this is what I'm trying to do. So Anoki is very much about people with common interests that are doing research, which is not very well defined on what is research. We have a few things that are part of research, but there are many different ways of using it. WikiDev is a little bit more instrumented because it integrates knowledge from different tools for software development, and MERITS is out there that has the specification of the procedures that need to be coordinated. So let me start with Anoki. So this was the tool that we built on Mediawiki to support our team. And we figured that the idea was that we need to accommodate a large group of people that stay and go in different ways, and they don't and communicate with each other. They have sort of well-defined tasks. So some of the well-defined tasks are things like literature survey reviews and maybe reporting, depending on how they're doing that. And sometimes they share artifacts. What can you be sharing? So the paper reading is something that we wanted to share in order to be able to have bibliographies on demand, reviews of things that we have seen on the web. And maybe there are some roles. So you have somebody who's a student, you have somebody who's a summer student working for a graduate student, and maybe you want to make these roles explicit or not. But that was kind of the general specification. So for that reason, we figured a few of the problems, a few of the needs that we had that Mediawiki did not cover already were things like access control, because although we're a pretty flexible group, you don't necessarily want to open completely all your half-baked ideas to everybody. So there should be some way of controlling who has access to what piece of information. We built page templates in order to allow structured data. Wikis are very flexible. You can do whatever you want, but if you don't have an idea, then the information is just completely lost and ugly to access. You don't know where to find things. So if you have a structure in mind, that usually helps in providing the right information. We built lots of visualizations for people who wanted to look at the data in a non-textual format, and some of these ideas came from education, where people started talking about students with multiple intelligences and visual learners. And we started working on understanding the evolution of wiki pages, and that went both because I was interested in the evolution of software and because my business colleagues were very interested in contribution analysis. So the artifacts change, and this change implies contributions of the users who change the artifacts. And finally, we started gluing this Mediawiki with lots of different tools, and we started doing some work on standardizing. How do you put information from external tools on Mediawiki? This is very much ongoing. So first, the access control. Mediawiki we're all familiar with Mediawiki to the extent that, well, for sure you have used it to find information. And everything is open and free, and that was the idea of wikis.
That's the Wikipedia?
Yes, that's the Wikipedia. And everybody can edit it, and basically there's one global area where everything is. Nevertheless, Mediawiki has a namespace mechanism, and this helps to organize information. And we use that namespace mechanism to piggyback a cheap access control mechanism. So when you become a user in Anoki, you get your own namespace. And the namespace contains the pages you create and contains you as a user. If you want to have a group, a bunch of people working on the same activity, then you can have a group namespace. and then you can place pages in that namespace. And pages individually can be moved around, so you can do exceptional moves, and a page can belong in multiple namespaces. So this is a cheap way of making something private. It has worked quite well for our purposes because we're really very flexible on who's working, who's supposed to see things. But now we're pushing it to more formal organizations. If you have an explicit structure that says this is a project, when we try to push it, for example, it works well if you have a good structure. So in WikiDev, it works well because we know these 4 students work on the same project and they're a team. And they can see everything. And these 4 students are in a different team and they cannot see each other's stuff. So if it's that clear, it works fine. If it's completely fuzzy, like research, it works fine. If it's anywhere in between, then it's very difficult to understand and have a systematic mental model of which page should belong where. And that's an interesting problem when you start with something that's completely open. Visualizations. So we have 2 visualizations. One is the Wikimap, which gives you a high-level view of all the content in the wiki. And the other is the Wiki Graphical Organizers, which gives you a visual view of the structure of an individual page. Both of them are built using Flex and Flash, and they're working pretty well in almost all browsers. Let me talk a little bit about the Wikimap, which was the earlier work. The idea was that people get lost in hypermedia, and you don't know where you have been, and you don't know where you should be going. So at that time, I had a student who was interested in so-called topic maps. Topic maps was a standard, an XML standard, is a standard. It's been evolving, sort of. But basically, the idea was that it was a language that will allow you to describe semantic networks, sort of, in XML. So we took this idea and we basically translated the wiki structure in so-called topic maps. And you have a graph-like representation where the size, the color of the node corresponds to the type of the node, whether you're an author or a page. And the size of the node can correspond to different metrics. The size of the page, the number of revisions, the number of links that point to it, and so on and so forth. And we started this work in parallel with Anoki, as we were working with Wikipedia. So we started the visualization part in parallel with Anoki. So the evaluation that we have is not really done on Anoki. So what we did is we took the design patterns wiki, which is a T-wiki, I believe, and we crawled it. And we built a Wikimap interface on top of that wiki. And basically the idea was to figure out whether indeed having this graph allows you to find stuff more easily. And we took students who had done design patterns and who knew the language, and we designed 6 questions, 2 difficult and 2 easy questions. And we split the 6 students in 2 different groups. Some of them got the vanilla version of the wiki first, and some of them got the visual version of the wiki. And we asked them to answer the questions, and we mixed up the order of the questions, the easy and difficult questions. And basically, this is the complete data set in terms of how long they took to solve the problem, to answer the question, and how many pages they visited to answer the question. And I can find the questions if anybody's interested. So in the end, we figured out for the difficult questions, the difference that the visual representation made was significant in essentially 2 of the questions. So the 2 stars basically say that both the number of clicks and the number of pages visited were significantly smaller in the end week, the visual condition, which was basically well, it was the right answer. That's what we wanted to see. Of course, the experiment is small, but people actually said that they like the view. Yes?
In the visualization, is it iterative? Like as you explore pages, the nodes show up, or do you just see the whole thing?
No, it is iterative because basically it's very ugly otherwise. And it can get ugly very suddenly, which is something that's annoying to me. We haven't thought how to solve it. But basically you start with a point, and then you see your neighbors, and you can filter. I can show you. So that's Anoki. And let me start with recent changes. that's vanilla Mediawiki. So let's start. This is the page that one of my students maintains for his to-dos. And if I ask to see the Wikimap, I should be centered on that page. So this is the page, and it is linked off the vanilla page for Michael. And one of the things that he needs to do is the paper that he needs to write. So this is link from updates to the current page and from the current page to another one. And these are us. And the size of our names has something to do with the number of revisions of that page. So I think I started this to-do list, so I'm bigger than Mike right now. So if I wanted to go to this paper, then it will be smaller. I never did anything on it. And if I go to Mike, and so on, for you get the idea, now you get this one. It will become 141 nodes. And just for fun, this is how useful it becomes. So depending on the content, things can be completely meaningless. But yes?
So in those difficult tasks, how?
You see, the good thing about that wiki was it was a good structure to begin with. The design patterns wiki has a bunch of paths that tell you how to read the book, the design patterns, how to explore the design patterns wiki. And for every design pattern, there is a good structure that points to examples. So the connectivity of that thing was very nice. We didn't have this ugly view. So you cannot solve the problem, really. But if there is a logic on how people structure the wiki, then it will help your life. Sheila?
Well, there are layout things you could try. I mean,
I'm sure.
yeah.
So you'll tell me.
Well, like you say, you do need to have some kind of structure, some kind of notion of order. You could pick it up perhaps even from temporality of when web pages were created or last touched, but you need to have something to use.
You see, the thing is that I agree, and I think that all of this have to do with the particular domain that you're looking at. This has been alive for way too long, and I can give you stats on how many people have used it and how many pages there are. And the people that are using it are very different. They have different structures. So I have been the only person that uses it for a long time, and I cannot come up with anything that would be meaningful to me. But for smaller domains, I think it would be.
I mean, 10 years ago, the graph community said that if you've got more than 400 nodes, you aren't going to be able to do anything useful on screen. There are people who think they have better layouts. In practice, I think probably it breaks down. But I think here you probably, I don't know how many you've got here, but
These are 150.
maybe like maybe 50 or 60 or something.
141.
140? That should be handleable. But it would really mean going through graph run layouts and picking out something self-annealing, something, you know?
You can do things, basically you can filter the old ones, things that haven't been touched. Depends on what is the logic of what you think you want to do with it. So we haven't done much, but if there is a structure and if there is a logic of questions that you want to ask, it worked. So people liked it, and it was kind of cool. I mean, if you, in some sense, the wiki had all these links that told you how to, the design patterns wiki told you how to follow it, but the visual view was also appealing. You get all the default nice answers about, I can find the relevant path, and it is easy to navigate, and I know where I came from. So we have some nice quotes about what people thought that was good for. And that was the one experiment. And then since we had the implementation of the graph, and we started working with education people, we discovered electronic graphic organizers. Graphic organizers are visual structures that are used primarily by elementary school teachers to teach students higher order analytical skills. If you're familiar with Bloom's taxonomy, learning can be either rote or more complex, where you do synthesis comparison analysis. And if you want to do synthesis comparison analysis, you have a bunch of graphical organizers that help you organize your thought around a persuasion argument or a story graph. So you get a structure, and it gives you basically the words in terms of which you you tell your story. And so what we did is we built 6 of these types of graphical organizers as we found them in the education literature, and we built graphs that basically translate into a page structure. So what you see here, this is the same tool, essentially, the same software, but here you edit your graph, and this translates into a wiki page. And you can go back and forth and edit the wiki page or the graph, and basically you can choose your preferred medium. The idea for that was that people would use these graphs to parse out natural language stories. It was meant to be story understanding. You have a story in your wiki page, you extract the meaningful storyboard in a graph, and then the teacher would be able to do comparisons at the graph level and the wiki page level. We actually did not do this experiment. The collaboration kind of fell through. But right now, we have deployed Anoki with a group of digital humanists, and they like the graphs. They're using the graphs to basically lay out some of the types of analysis they want to do for the documents that they're reading. So this is completely anecdotal, but that might be a venue for where to evaluate this toolkit. The other thing that was interesting in Anoki is this notion of contribution analysis. Wikis are all for everybody to work together and write pages, and when you see a page, you don't know who did it. But some people, wikis are used in organizations, and in an organization, if you contribute something, you want usually credit. Same thing in education. If our students write something and they write documentation, they want to know that they contributed the good ideas. So Mediawiki has only counts of how many times somebody edited the page and how many letters they changed, how many characters. And we decided that this was not meaningful enough, so we built a sentence comparison algorithm. So basically, we keep track of who owns every sentence on the current page. And if somebody edited a sentence more than 50%, then they take ownership from the previous owner. So in the end, we have metrics of how many sentences every user owns at the end, how many sentences they edited. Proofreading basically means minor changes that do not change ownership. How many sentences the user deleted, how many links they added, and whether they changed the structure of the page by introducing headings. And we associated these different metrics with editorial changes like adding content or deleting content that's directly relevant, or reorganizing, restructuring the content. And we built visualizations. So this pie chart basically says that every slice of the pie is a user, and every ring is a type of change. So this basically reports that this guy here added 130 pages, deleted, what's that? I can see it on the wiki itself. But basically, you have a quick view of how many changes of what type every user did. And this is for the top X users. If you have way many users, then the least contributors get lumped in a small pie slice. And we did an experiment with that. We took 9 Wikipedia articles, and we checked out all the revisions for 3.5 years, and that ended up being 130 different contributions by 105 authors. And we had 2 markers go over every change and tell us whether what type of change it was, and they had to choose the top 5 contributors for every page. And we tried to figure out whether our metrics correlated with people's perceptions of contribution. And we found that. So what did we do? We found that the number of characters that comes by default from Mediawiki, the total number of sentences that a user contributed, the total number of sentences that the user has in the current version, the most recent version, and the total number of sentences that lived long enough, weighted by longevity, were all meaningful. So basically, that was kind of disappointing. Even the simplest character count strongly correlates with people's perception of who added more stuff. You don't really need all this fancy analysis. At least our fancy counts are slightly better than the character counts. And it turns out that the total number of contributions, not what ended up being on the page, and not how long they lasted, just the total number of sentences added was more meaningful. So the last table, the same thing with the deleted category. people. The last table is trying to come up with a statement of what makes somebody be perceived as a top contributor. And this was also very strange and disappointing, because what we try to do is we try to combine all the metrics and figure out which metrics correlated best. And we figured out that the metrics that correlated best were how many hyperlinks were added and how many deletions were made, which is completely unintuitive and doesn't make much sense. So still, the notion of what makes somebody a top contributor, we do not know based on this algorithm. And it doesn't make any, we didn't come up with any intuitions on that. So,
I think the internal hyperlink kind of makes sense. Because people with more experience with Wikipedia tend to link more often.
yeah. Yeah, basically you're saying you're building links and you're making things more accessible, so you're contributing in the things being found. But
also like many different ways, like some people just check the quality of Wikipedia pages and add these things.
yes,
I was wondering, so you say these correlate well with the perception of who, so I'm kind of wondering is where does this perception come from?
okay, so basically we had 2 markers and we told them to go through all the 9 pages, bunch of revisions. And they went through all the revisions of every page and they came up with the 5 top contributors. They read everything and they said who,
It's people
yeah,
reading.
2 real people reading and saying these are the 5 people that are top.
What was your ground truth data as to what was the right answer?
Yes, because
We don't, there is no ground truth with the exception. The 2 markers agreed, that's one thing. It was 2 independent markers.
So is the data you're showing about their agreement?
No, the data is combinations of our metrics, added sentences, deleted sentences, weighted by longevity, against their assessment of who's the top contributor. So the ground truth is the 2 markers together because they had excellent agreement. Basically, they agreed pretty much, I should find that they agreed almost completely on who are the 5 contributors, 5 top contributors. So,
Did you ask them to speak about how they did that?
no.
and were they knowledgeable of the area?
The areas, I can
Were they-
find the pages. The pages were all over the place. They were not necessarily in any area and they were not necessarily knowledgeable.
But
So,
were they even knowledgeable of the community? Because there's always this notion that, you know, the more famous people who have been writing get perceived as being more important.
okay.
So what I'm wondering here is I think there are 2 things that are
go on.
interesting and questionable, and one is like exactly what you can do that represents who are the main contributors,
Mhm.
and whether or not you are comparing them against something that is really what's happening.
So, let me see what you're asking. Okay, so I can find the 9 pages. They were all over the place. One was a movie, Erin Brockovich. The other was a city. I don't remember all the 9.
The real question is,
Yes.
you think there's, I think what comes to your notion of ground truth is like we don't really know if these 2 markers, I mean, the fact that they agree, that's strong.
Yes. And they were not experts in anything, so I think that if we were to look at people's contributions in some Java-based wiki, then it would be a different type of ground truth because somebody would tell the right answer. And then the fact that you're talking about it might not matter. So we haven't done this. There's no domain expertise. We don't know who knows the truth. It was a very vanilla set of 9 pages, and it was very disappointing in that sense.
Assess your algorithm.
Yes, there's tons of work to be done here. Because basically the idea, what my colleague wanted to do was to make people do the right thing. So one is to figure out what is contribution, what is perceived contribution, and then the second one, how is to visualize that in order to make them not loaf. So if these are the pictures that show contribution in terms of our metrics, would you make them add more sentences? And even if you made them add more sentences, still they wouldn't. Would that be meaningful with who's reading it? In this experiment, no. Even if they added sentences, it wouldn't count as much. So that's the circle that we want to close, and we're nowhere near that. But this is fun stuff. So the other issue of motivation is we're doing visualization to communicate and therefore motivate. And the other motivation thing that's happening right now is basically reward systems. Like there's a thing called seriosity, fake money. You give people fake money and they can do things with the fake money, whether it is stars or whatever. And then you see who's becoming richer by collecting money from their readers.
Have you considered doing anything where you actually read the semantics of the page? Because, I mean, a spam bot could just go in and add, remove, and change content, add links to a page, and your algorithm would think it knows which spam bot is the biggest contributor.
Okay, so no, we haven't done that.
A variation on that I was thinking about is you might have a contributor that adds a single word to a page, but it turns out the word was not.
Yes, yes.
And that was really critical to making the page be truthful as opposed to...
We're doing this now. Basically, this is sentence counting, but now we're looking at changing the polarity of sentences. So instead of simply saying that I changed it 50%, we're looking for polarity changes, and we're looking for interesting, lightweight parsing in order to get meaningful bits out of the sentence. I mean, so this is very interesting. We didn't look at spam bots, but these people read the pages. It was not. I mean, yeah.
It's also Wikipedia. Wikipedia has defense.
It is, yes. So.
Yeah, I mean, the other thing is that trying to boil it down to just sort of a stack ranking of people may be a naive model of people, right? I mean, it could be that, if you talked to people who are regular contributors to Wikipedia, they might be able to give you a rich notion of roles, right? So maybe there are like generators, and then there are nitpickers, and there are, I don't know, maybe there's a half dozen different kind of roles that people play out, and maybe automatically assigning people contributors to those roles algorithmically, that might be a more interesting problem than sort of ranking them.
We just took these roles from general editing theory. So basically, these people have done, I don't know the literature, but there are some roles in editing theories, how people contribute to text when they scribble on text. So that's where it came from. Then we had to massage them a bit in order to make them reasonably represented by our metrics in our mind. And this is how we try to close the loop. But you're absolutely right. I mean, maybe these metrics are completely unrelated with the roles that people perceive in different domains. So, but it's an interesting problem and tons of things to be done. So in the end, these are all the things that we did on Anoki. And right now, I'm trying to say, why is it a good thing? Well, lots of people are using it, and I'll tell you the truth. The first line is us, and there are 200 users, and lots of pages and page views, and it's actually used. All of my students use it, and many of my colleagues use it, and they have adopted it for their students. But again, this is us. But there are 4 other research groups that they have adopted it. Of course, it's free, and we help them maintain it. So, there are motivations there. There is a high school that's using it, and they have some good numbers. Basically, they had 200 students use it for recording their activities in language arts and, I think, science. And we have one organization that's using it for the template pages to keep track of their inventory. So that's a way of multiple people saying things about their machines and software and stuff like that. It's a boring use, but that's where this thing is. So that's Anoki. And on top of that, we started building the software engineering support. Basically, we used that to build a tool to glue information about software development, and that's the WikiDev 2.0. I'll skip that. There are 3 things that went into there. One was we want to analyze how software evolves, and we want to correlate how software evolves with how people work to make it evolve. We have done a lot of work on object-oriented evolution analysis. That was Jay Devan, basically extracting a UML-like model from code and doing a heuristic graph comparison to figure out how a code repository changes from one version to another. That was Jay Devan. And then you have all the people doing the changes, and it wouldn't be nice to understand how the people work to make this happen and how the interactions flow. And it would be nice to see whether formal collaborative environments and at some point in time, we examined both JAS, the IBM tool, and Doctor Project. Are you familiar at all with Doctor Project? That's a homemade tool that Greg Wilson had built. And he started from track, SourceForge thing. So he started building his own homemade tool. And we had started building WikiDev, and then JAS came along, and we started looking at all of these things. So this is the intellectual baggage on WikiDev. So Anokhi is the glue among these tools, SVN repositories, Bugzilla, mailing lists, and IRC channels. So stuff from all of these 4 things go into Anokhi and become wiki pages. And we have built a bunch of analysis, namely UML diff that analyzes the code, gets results into WikiDev. We have an interactive UML viewer that is the same thing as the original Wikimap. And we have a bunch of lifecycle statistics about who did what and who talked with whom. And we have an artifact clustering mechanism to try to correlate artifacts from the SVN repository with Bugzilla and mailing lists and IRCs. And that's a not so pretty picture of the text. So SVN, real wiki pages go into the database, Bugzilla and mailing list, IRC is missing here. And I'm going to talk about these 2 things, the artifact clustering and the communication analysis, basically how people talk to each other around code. So the clustering basically, since you have all these artifacts, SVN commits, Bugzilla tickets, mailing lists, and IRC chats, all of these things become wiki pages. We want to cross-reference them, link this data, and make sure that you figure out how they relate to each other. In principle, what you want to ask is, why did this change happen? Was it a discussion in an IRC that I had a problem and you have to go fix it? Did somebody put a ticket? Was the ticket closed in reference to something else? Who are the people that talked about a particular artifact? Who are the people that contributed most? And is there an influence path from one person to another? So these are the questions that we want to ask about. And as I was reading the codebook paper from last year and the Tesseract paper, you all have scenarios of what we think we want to answer. And everybody's kind of hitting similar points, I think. And the question is, how do you cross-reference these materials? So what we did is basically we do document text parsing at this point in time. And we cluster all of these artifacts according to the text that they contain. So we have a bunch of artifacts. And in Subversion, you have the commit text. And you have comments in the Java files and the names. And the change sets. OK, so basically, these are all examples of things that we have seen in one of our teams. And you're all familiar with the types of things that people say when they put stuff in Bugzilla or ticket systems. And OK, text analysis. So we take the text, and we use Porter stemmer to take basically the stem of the words. And we use TF-IDF measure to weight the importance of a term. And the next thing is the clustering method. So we're using a hierarchical agglomerate clustering, which is basically bottom-up clustering. In the beginning, every artifact is a single cluster, and you have to figure out how to glue them together. In order to glue them together, you have to decide what are the closest artifacts. So you have to have a distance measure. So we have 2 distance measures. One is, basically, we have different types of relationships. Starting from the SVN artifacts, which are basically the code, is that true? No, starting from the code elements, we're figuring out the explicit relationships of communication artifacts with code. So if there is a direct reference from the text of a ticket to a class, that's a relationship. And the weight of this relation, that's a direct relationship, an explicit relationship. And the weight of this relationship is the cosine distance of all the terms that they share together. And if there are 2 artifacts that are not connected to each other directly, but they're connected through another artifact, then we use the triangular inequality to calculate their distance. So now we have more distances to use in order to do clustering.
What's the unit of distance?
Ask me again in a different way.
So I know that these two artifacts share a bunch of words together. How do I tell what the distance is between them? We can talk about it later.
Yeah, you're throwing me off. I know that that's an answer that I should be able, but I don't understand your question right now.
Okay.
So basically, you have to figure out when to stop, and we did experiments to figure how far along do you go in merging clusters and how many clusters you want. And basically, this has to be a user-defined threshold, and we run a bunch of different thresholds, and usually anywhere between 2.5 and 0.7 works well, and I think the data I'm reporting is 0.7. Well, I talked about that. So that's, I don't think that's particularly meaningful, but that's one of the simulations that my student did. And here are some results. So we analyzed, at this point we're analyzing more teams, but really the clean data that we have is for one team over a 4-month project. They had 4 members, and that was it was a course with actual 9 weeks of development when they started the project. They had a bunch of email messages, 626 commits, 194 tickets, and they built their own wiki pages, 338 of them. And we sliced the evolution in one-time week windows. Basically what we did, we tried to do clustering on all this data, and it was a disaster. There was nothing interesting happening there. We couldn't find any meaningful clusters. So afterwards, we decided to take the data in slices of 1 week. We're trying to figure out coherent relationships within the activities of 1 week, and that was mildly more meaningful. We found some clusters, and then we went manually and looked at these clusters. So basically, one of the TAs of the course went and looked at the clusters and decided whether they were correct, whether they had extraneous stuff, or whether they were missing information. So the questions were, so the correct is basically, are all the elements in the cluster related to something that made sense to the TA as being an activity? Did we miss things, and are there artifacts that shouldn't be there? Okay, so here are the actual results. I told you there were 1,200 artifacts, only 90 were clustered. So that's good news, bad news. You don't want to have 2 big clusters because it would be more difficult. If you have bigger clusters and lots of artifacts in the clusters, it would be difficult to make a story about why they're related. Having said that, 90 artifacts out of the 1,300 makes, although we could tell a story about what these 90 clusters were, no, there were 32 clusters only. So it was fairly straightforward, and in all the cases we recognized that the clusters were, in almost all the cases, the TA saw that indeed there is a specific task that's going on here. This is a meaningful cluster that corresponds to an activity, but then we couldn't recognize many interesting activities. So clustering works, but not for much, I suppose. We found, for every week, we found anywhere between 1 to 10 clusters. So the end weeks had more clusters because they were more active. And I think I have a picture of exactly what the clusters were, a table. So this is the kind of analysis that we did. I know you cannot read it, but basically what we did is we built this table for every week. We reported all the clusters, so week 4 here, 1, 3, 5 clusters. And the TA went and said whether this cluster was meaningful. Close means this is an activity. It has stuff that is useless, that it is not part of the activity, or it's missing information. So the reason why we're missing information is because this artificial 1 week threshold. In many cases, we saw clusters that were talking about a problem that was addressed, but the ticket was introduced the week before. And in many cases, the closing of the ticket was the week after. So with a little bit of post-processing, we could find the extra stuff in weeks before or after and make the cluster coherent. Of course, we had some strange clusters that basically matched on weird words. So there was a word details here, C wiki page XYZ for details, or C a ticket for details. And this, since we cannot throw, since the text is very small, you cannot throw rare words. So sometimes you get accidents on very strange words that happen to be used at the same time, and you get a cluster on words that are not meaningful because we cannot throw them away. So what was the point of this exercise? I suppose the point of this exercise was that when you have clusters, you can show this. If indeed it worked, all these clusters would be meaningful for an instructor monitoring the team, to know that this is what they're doing now. They're addressing the problems. There is, for every ticket that's open, there is a discussion going on. They're deciding what to do. We're not there yet, but that's what we were thinking we were doing. And right now what we're actually doing is basically change the text analysis to be more syntactic. We're doing syntactic parsing, and we're trying to figure out more interesting relations about who knows what, who tells whom things, and try to have more meaningful relationships, as opposed to saying that these comments share words. I can show you Wikidev live, apparently. This is a team that was actually distributed, so we have been using it for our own course project with the teams that are in our campus. But this was a team that worked last term with me. 2 students were in Waterloo, 2 were in Simon Fraser, and 1 was in Victoria. And I never met them, actually. So we have been using this for real. And here is every team gets by default this index page. And here are their mail exchanges. Every team gets by default the mail list server, where everything gets sent, and everything becomes a wiki page. So there is a long discussion about updates for this week, I think. This is when we started, September of 2009, and user 4 is me. We have a cheap and dirty anonymization. It's a little bit ugly, but basically this is me telling them that this is what we're doing, and you can see some names here. Every message comes in. We try to separate every message from the rest of the messages that are included. This does not always work. Here it didn't work. There are several interesting problems apparently with that. So one thing that we can do is basically we have all these default representations. So anything that is an instance of the same structure can become a table in Anoki. And this is a service that you get for free. For whatever type of information you have, you can see it as a table that is sorted. Oops. So the other thing, Bugzilla at the back end, we have a process for sucking the data from Bugzilla, and we have a view of the tickets. I cannot show you the tickets because the anonymization breaks the connection with the real Bugzilla. You cannot anonymize the real Bugzilla. So, but from here, every one of these things can take you back to the Bugzilla data. Wiki pages, these are all the wiki pages that people are actually built, and we have a report about who modified them and what was the last time and the number of revisions. And we try to visualize the communications. Did I click on that? So this is the part that goes closer to social networks. And we have a bunch of graphs. And of course, as luck would have it, some of them are broken right now. But what you can see here is how many these blobs corresponds to the number of tickets that these users had in common. And you can see user 5 and 6 had a bunch of tickets working among themselves. They, in fact, were a sub-team. And these counts are counts for 9 and 5, 8 and 7, and it's the opposite one. 7 and 6, 8 and 6, and 5 and 8. So here we can see that these people were using the ticket system more effectively than the others, because clearly all of these kids did pretty much a similar amount of work, but only these 2 guys used tickets to communicate explicitly. We have similar visualizations for the messages that they exchange, so you can see who's talking to whom. And again, these are the same people that form their own sub-team, and they're communicating through emails. And this is only one team, so it's difficult to compare with other teams and see whether people are using tickets to communicate with each other formally, or whether they're doing things in IRC or messages. And the last thing that I want to show you is the UML viewer, which is basically the same thing as Wikimap, only more UML looking. And for example, let's say that this looks a little bit more like UML. So you have information about classes interfaces. And the thing that's interesting here is you can have the classes annotated with information that is extracted from code analysis. So you can see the number of revisions that the class suffered. This comes from J. Devon. Or you can see the people who revised the class, I think. Let's see that one. So you have the process information. Okay, this is a very small view. And let me see if I can space the items a little bit. Squeeze things. Okay, so you can see a few things here. But basically, this is what I wanted to do since the beginning. Have a code view that is accessible on the web. On top of this code view, you have annotations that come from the process. I know how many times this thing was revised. I know who edited it. And now we're building more queries to use information from J. Devon, like coevolution. These two classes change together. This stuff could become annotations on this view here. And all of that is basically accessible in a lightweight manner. It's not locked in a particular development tool. And this is what actually the team did last term. This distributed team, they built this interface. And I think that's all about WikiDev. I showed you all these pictures sort of live. And the last thing that we're doing right now is 3D visualization. There's a lot of work on 3D visualizations in cities. But as far as I can tell, nobody has done usability studies on that. Do you know of any usability studies on 3D uses? I don't think it's actually on the software visualizations in 3D.
Not particularly software, but in general of using 3D in Viz.
Yeah.
A very large camp that is really, really anti-use of 3D in Viz, and they've got all kinds of reasons.
Okay. Actually, this agrees with my intuition. I don't like it.
So that the person who's got the strongest voiced opinions against the use of it is Ben Schneiderman, but I'm not sure if he's particularly done any studies. Colin Ware has definitely done some studies, though they actually show some advantages.
Okay, so that's an interesting...
There is a quite fierce and ongoing discussion in the Viz community about whether or not...
I'll send you an email and you can send me some pointers. I have looked at all the 3D visualizations in the software engineering community. Nobody has done any usability studies. And most of the things that I have seen are completely meaningless to me. Honestly, I kind of like the city metaphor because I understand it, but I have no idea whether it would be useful to anybody. In any case, we have virtual worlds experience, and it was just so easy to build on top of WikiDev, so we just did it, and we're trying to do some studies.
I think the strongest anti-3D stuff was probably in Tufte's first books.
Tuft?
Tufte.
Oh, okay.
T-U-T-F-E.
Okay.
Which were published in the 80s.
What domain?
Graphic design.
Okay.
They're great books. They're really fun, but he's got all kinds of examples with big explanations about why the use of 3D turns a visualization into something that misinforms instead of informs. Then subsequently, in the mid-90s, he's published a book of how 3D can be used effectively. So, but
it sounds like a religious fight over there. These are fun.
But there are some, but not enough, of course, actual studies.
And there is none. There are several papers. We just did this research. Several papers in ACM and IEEE on 3D visualizations of software, and there is no experimental evaluation at all. So. The reason why I was particularly interested in this is because we started doing work in virtual worlds, and we had another project that was visualizing basically buildings. We were working with civil engineers. So we had a sort of a library in Wonderland for drawing buildings and laying them out. So we used that library to draw classes. And we had the clustering that basically identify distances between artifacts. So once you have the distances, you can put them into place, and then we did some massaging to put them in blocks. And then we had the layout, the 2D layout, and then we had the library to build the buildings. So that's where this thing is coming from. And there is some story about how to place things. There is a city that has the software core artifacts, and there is an industrial area that has the communication artifacts. And the colors correspond to users, and you can see the top of the city and figure out who did something where. So basically, I want to do a study. We haven't decided exactly what are the types of questions that we will do, and what we're doing now is we're revisiting all the questions that people posted in Codebook and Tesseract and the things that we have been discussing to see whether we can make up interesting mappings for these questions and whether people would perceive them in that space.
Shows positive effect for 3D.
Oh.
There were subsequent studies from Andy Coburn of actually moving it off the virtual and into the physical that shows it doesn't work in real life.
And that's positive?
No, the first ones were positive.
Okay.
Can you just briefly say what we're looking at here? So the z-axis is definitely some metric.
Yes.
What are the x and y?
The x and y are coordinates that have, so...
is it just sort of like a graph affinity kind of thing where you related things together?
So we build the distances based before in order to do the clustering. So once you have distances, apparently you can translate them into coordinates, MDS. So you put them in coordinates, but the coordinates can fall on top of each other. So then you do someone's algorithm, which moves things around, and then still it doesn't work. We came up with this idea of neighborhoods. So every neighborhood, I think, has 16 buildings. So once we had clusters that were too big and so every cluster could not be in one neighborhood, we built a bunch of peripheral blocks and we started pushing things out, and that's the way we laid out the city. So there is one city for software artifacts, and there is one city for communication artifacts. And the height corresponds to particular metrics. And I can tell you the metrics, I have to figure them out. Let me go to my presenter tools, because I don't remember them off the top of my head. So, yeah, that was good. So the artifacts are, for wikis, how many edits they had, the height for tickets is priority, and for every file is the number of changes they suffered. But all of these things are, the thing is, since we have the library that lays things out, we can actually even change the heights interactively. That would be definitely epilepsy kind of thing, but we can try different scenarios with different heights. So that's all with software, and the next thing I want to briefly mention is the work that we're doing on training people to collaborate in virtual worlds. So before I switch to something that's a little bit more strange. Any other questions here? Okay. So this is new work that we started doing with people in the health sciences, and the problem is that basically they don't talk to each other, and our health scientists got a grant to help interdisciplinary practice through simulations. And basically what it means is they got mannequins to put people together and do simulations on mannequins. They have funds to use simulations with standardized patient actors. So what you do is you hire an actor to be a patient and to enact the story of the patient, and you have people at the same time physically talking with the actor who's pretending to be the patient. And we're mimicking these activities in 3D virtual worlds. So basically, we're building a non-plane character who is the standardized patient, and we have the various team members meet and talk with the person and do diagnosis. So we actually have two projects there. One is the InterD410 course. This is a course that all health scientists take. So it's a huge course, and in there, currently they're using Illuminate to meet, which is basically a teleconferencing tool. And they see the video of the person. First, they see the first interview with the character, and they take some notes, and then they meet and they plan, and then they meet the actor, and have a second interview with a character that has already been admitted to the ER. The more interesting thing that I'll talk about is the EMS ER handoff scenario. So basically, this is a collaborative activity. You have EMS people, emergency medical services. They go on the scene. They have to take care together in a coordinated fashion of the victim. They have to communicate about who's doing what. Usually there is a primary and secondary, and they have to play it out in real time. And then they have to move this person to the ER, and there they have to tell the history of what they did and what they know, and to pass on the responsibility for the victim to the ER personnel, which involves all sorts of different types of specialties. So everybody will come in and see if they need an orthopedic person or a neuro person, depending on where you have hurt yourself. And apparently there are many studies to show that the lack of communication is the cause of many missed information from the EMS to the ER people, and that's bad if information doesn't pass. So I'll tell you a little bit of what we did for that scenario. This is what they gave us. They gave us a storyboard of how this EMS ER thing works. And they built it, and they told us the story, and we were supposed to build it. And this is what we ended up doing in basically Second Life. I can show you a video of how it works. But before we get there, let me tell you what is the support for that, what is the software that we run. So we started from wikis where people just tell things. Then we went to Wikidev, where people actually have tasks with bugs and tickets and code editing, and they use specific tools, and the nature of the communication is more structured. And now we're going to a process where people collaborate in order to do specific interactions. And there are proper procedures that they have to follow. Not everything is regimented, but there are some procedures. So here is the part where we can actually, we have to introduce a workflow of what's the right way of dealing with the victim. And this is very tricky because not everything is instrumented and regimented. So basically what you have is and it's also very contextual. So one of the things that they want to see is the patient has a bracelet, they have to notice it and they have to investigate what the bracelet is for. If there are bystanders, they have to ask them information. If the person is bleeding profusely, they have to wear goggles. So these things, we cannot program them completely. So what we have to do is we build a mechanism by which we model the physical artifacts that are part of the context, and we model their behaviors in BPEL workflows. So if there is a bracelet, it has a behavior. It needs to be checked, and when it is checked, it gives you information. And all of this stuff can be programmed by the simulation instructor. So what's going on here is basically there is a workflow. There are a bunch of workflows for the individual entities, and there is a normative workflow in the sense that there are a bunch of constraints. If the person is bleeding, you have to have goggles before you touch them. Otherwise, this is irrelevant if the person is not bleeding. And in order to build these workflows, what we did is we actually asked our colleagues to tell us more detailed information. So we used Anoki, the page templates. For every picture they gave us, we asked them questions about what objects need to be there and what the characters need to do and what are the activities that need to be supported. So we have a bunch of structure pages where they went and edited more information. From this information, we built the workflows for all the behaviors of the objects in the scenes. So the scenario specification was tricky, and we had to go multiple times back and forth. What is very tricky here is the nature of virtual worlds. They're very mature, and basically you cannot do many things. It's very difficult to have coordinated activities. Shaking hands with two people doing the same coordinated activity at the same time is difficult. Manipulating one single object like a spine board in a coordinated fashion is difficult. So there are activities that are very difficult to model, and the realism of the worlds is different to a different degree. So you can spend much time making things very precise, and we do not know how much of this we need. So these are the two problems that we're facing. Let me show you how it looks a little bit, just to get a feeling for how it is. I think, let's see, I'll go outside to the browser to show you. So the question is how much realism you need, because now the spine board, you tell the spine board to go close there. But this is not particularly interesting in terms of communication. What is interesting is they have to talk to each other to figure out who's going to do the head and who's going to do the feet. And they have to touch the victim in the right places to ask information. So the victim is a composite object, and you can have information about how does the blood look like, and you can have even sound to listen to the heart. I don't think I have it now, but basically, depending on where you touch the victim, you get appropriate questions to ask. They told us that they do not want inappropriate questions. And at some point will come the other guy, and they have to work together in order to place this person. And there's also timing information, because you have to finish that fast. Otherwise, apparently, if you don't do it in, 20 minutes, then that's a problem. And of course, you don't know how to translate 20 real minutes to simulation time. So this is something that we're figuring out. The simulation is not, this is very jumpy. It's basically because it's a video recording. It's not as jumpy. It's much smoother. But it also depends on the platform, on the machine that you're using to run it. So this is what we're doing now to train people to collaborate and communicate in this particular scenario. And how does this relate to anything? I'm interested in using these platforms. These platforms are free, they're quite capable, and they support interactions. And what is interesting is you get a learning curve, you get higher in the learning curve. Most of our students have experience with wikis, and we find that many people actually have experience with Second Life these days. I don't know if this is going to be true, if Second Life will survive, but the point is that many of our students actually know how to move in the worlds. So you have many more interactions that you can help them train, and many more interactions that you can record and recognize how people communicate. So if we were to move these things together, this is what I think it would look like. Basically, we're looking at how people work with stuff. So we have social entities and materials that they communicate through. In Anoki, we have team members, so the roles are kind of fuzzy, and the responsibilities are very vague. In Wikidev, we have developers, and in some teams, people classify themselves as testers or as front-end developers or as back-end developers. So you may or may not have roles. In Marriage, we do have roles. The roles are very well understood and defined, much better than in the other spectrum. So you have a spectrum of social entities with the roles, and to the degree to which their roles are prescribing them activities. And then you have staff. In Anoki, simply communication. In most wikis, people write information. It's only text and it's unstructured. In Wikidev, you have real artifacts. You have tickets, and they have a structure that can tell you who caused something to happen, and there are more interesting relations that you can extract from them. And again, you have communication. People are just talking in IRC. Maybe they're saying something meaningful, maybe not. In the virtual world scenario, you have even more interesting communications. People interact through physical objects. They have to coordinate their interactions through physical objects, and the physical objects have affordances that allow people to do the right thing, and things are synchronous. Many things are synchronous, while at the same time you still have people talking to each other and exchanging information. Talking about contribution and how people behave and how they influence each other. In Anoki, it was simply about who changed what page. In Wikidev, you have basically somebody who did a test and discovered a bug, and they put a ticket. So you have specific artifacts whose evolution implies specific paths of influences. So how can you correlate this? How can you correlate the impact that somebody has in terms of what they say when they say something in IRC, and it's similar to when they do something in a ticketing system? And you have to combine these two. And in the Marriage, we're also looking at nonverbal communication. So we're building explicit gestures so that people can communicate the fact that they're getting antsy, if they're getting antsy with somebody's type of questioning. So there's another way of communicating. And in terms of analysis, the things that one would be interested in doing, I think, are how does the content change and how that implies contribution? How do you recognize the roles that people assume based on their actions and based on their contribution to artifacts? And in Marriage, we're also interested in figuring out whether people are doing the right thing. In Anoki, there is no right thing, and in Wikidev also there is no right thing. People are just simply contributing to changing the code. But in some cases, some collaborations, you have prescriptions of how people should behave. And you want to see whether they're doing the right thing. So in the end, I think if we were to try to find out more general words to describe collaboration, I would be interested in looking at primary materials like code artifacts, annotations on these materials like tickets that talk about classes, and simple communications, things like IRC. And in marriage, you have verbal communications and non-verbal communications, and you have interactions with physical objects. And the relations that we're looking at are co-production, co-usage, influence by making somebody take an action. So my action may cause somebody else to make an action. And also we have organizations that tell you what you're supposed to be doing. If you're a nurse, you have to do these things. And you always have to defer to a doctor, because these are the rules. And then the analysis that we're interested in doing is impact, something that we have started. And then you can ask questions about how important an individual is in social networks in terms of how they communicate, and also how much interaction there is in a community. So we saw the small teams that were talking to each other, the sub-team that had lots of exchanges, both in tickets and in messages, and then the other people were not very cohesive at all, although they were working together. So I think basically trying to come up with a set of interesting questions for studying all these collaboration scenarios together, these are the words that I would like to pursue and find semantics for in all these three instances. And there's tons of work to be done, but I'm very interested in the potential of both these platforms in terms of practicing collaboration and supporting collaboration. So thank you for your patience. Okay. So hopefully.